Bienvenidos a todos, el problem set 8. So notice that it says, please work on a separate page. So that's what I'm going to do right here. Of course, I'm going to change the function, but I'm going to do the same work as what's expected here. So first of all, we need to find the derivative. Like I said, I chose a different function, cosine plus cosine of 2x. First of all, the derivative. So of course the derivative of cosine is negative sine, and the same with this one, negative sine of 2x. But then with this one we also have the chain rule, so multiply by 2. Then we are going to set it equal to 0 and solve for x. But I'm going to need to use a trig identity for this because when you're solving trig equations, the arguments need to be the same. So for this one right here, I'm going to use the identity that is equal to 2 times sine of x times cosine of x. And then I'll just take this 2 and move it to the front, as well as that negative sign. And then set the derivative equal to 0. And then we need to solve. So you can see that there's a sine of x right here, and there's a sine of x right here. And also they both have negative signs, so I could factor out negative sine of x. And then what remains? So when you factor out a negative sine x, that leaves a 1. And then I factored out the negative, so that's gone. This is going to be 4. Oh, my little cosine lost his x. So it's going to be 1 plus 4 cosine of x. Now that it's factored, set this one equal to 0. And set this one equal to 0. So with this, you could just multiply both sides by -1 and get sine of x equals 0. For this, move the 1 to the other side, it will become negative, and then divide both sides by 4. So this one is saying, when does cosine equal -1/4? Now with this one, I could just take a look at the graph of sine, which looks like this. And it equals 0 right here, and right here. So that would be at 2 pi, at pi, and at 0. For this one, cosine equals a -1/4. So the cosine graph goes like this. Right here is 2 pi. And then on the y-axis, right about here would be -1/4, and if you go straight across, there's going to be 2 solutions. Now the first solution you could get from the calculator by using cosine inverse. So make sure that it's in radians and find cosine inverse of -1/4. 1823, 1.823. Now that means that this x value right here is 1.823. And that means that the length from the beginning of the graph over to here, that length is 1.823. Because the graph is symmetric, over on the right side, this is the same length, 1.823. So in order to get to this point, it's to the left of 2 pi, so it's going to be 2 pi minus 1.823. And then 2 pi minus 1.823 is a 4.460. All right. Now start transferring that information over here. So of course this isn't this function, it's that function. So we've got the derivative is negative sine of x minus 2 sine of 2x. The critical values, that's what I just worked so hard to find. So that is the 0. And I think I'm even going to put them in order. Next would be 1.823. And next would be pi. And then 4.460. And then 2 pi. The next thing to do is put those on a number line. So there's the 0, there's the 2 pi. So I just need to fill in, here is 1.823. Right here is pi. And here is 4.460. And all of these values are where the derivative equals 0. So this information is going to be about the derivative. So the derivative equals 0 here, 0, 0. And then I want to see where's the derivative positive and where's the derivative negative. So graph the original function, cosine of x plus cosine of 2x. Make sure that the window goes from 0 to 2 pi. And when you put 2 pi and you move the cursor, it gives you this decimal approximation, which sometimes cuts the graph off and doesn't include that 2 pi. So I usually just make this a little bit bigger, like 6.5. And then the y values from -2 to 2. And then take a look at the graph of the original function. So first it goes down, and then up, and then down, and then up. It makes a little W. So this point right there at the bottom, that should be this 1.823. Yes, that one's correct. And at the bottom right here, that should be the 4.460. Yes, that's correct. So from the top to the bottom, the derivative is negative. So this is, trying to fit this all on the screen. So this is negative in here. And then from here to here, that's this part, so it's going up. So the derivative would be positive, it's going up. And then it goes down, and then back up. And then when you make this little chart right there, you can basically just read these answers off of it. So increasing means when the derivative is positive. So that's this interval right here. So from 1.823 to pi, and then also this interval is increasing. So 4.46 to 2 pi. And then for decreasing, that's going to be this interval. So from 0 to 1.823. And then from decreasing, also from pi to 4.460. All right, then what about minimums and maximums? So actually that's one minimum right there, and then this is another minimum. So for minimums, so this is saying what the actual point is, so then put the x and the y. So that is 4.46 comma negative 1.125. And then the other one was 1.823. 1.823, the y value is the same because the graph is symmetric. And then for maximums, there's 1, 2, 3. So one of them is when you plug in 0, it equals a 2. And then another one would be this right here, and that's going to be pi 0, pi comma 0. And then this one should be 2 pi comma 2. Okay, now we're done with the first derivative. Let me just set this aside. Okay, so for the second derivative, of course, you start with the first derivative, which was this negative sine of x minus 2 sine of 2x. And now take the derivative of the derivative. So the second derivative will be the derivative of sine is cosine. And here the derivative of sine is cosine. But then don't forget the chain rule. The derivative of the inside is a 2. And we need to set this equal to 0 and solve for x. Just like last time, we need a trig identity. There's actually 3 trig identities for cosine of 2x, but I'm going to use the one that says it's equal to 2 cosine squared of x minus 1. Because then this has cosine of x and this has cosine of x. All right, now I need to take that 2 and that 2, put them together to make a minus 4 right here. And then you set the second derivative equal to 0. So when you distribute this negative 4, that's going to be negative 8 cosine squared. And then I would put this term in the middle, minus cosine x. And then a negative negative will make a positive 4. And then we need to do the quadratic formula. If it was algebra class, we would say x equals. But this is about cosine, so it's going to be cosine of x equals, and then the quadratic formula. So that'll go negative b plus or minus the square root b gets squared minus 4 times a times c. All divided by 2 times a. So this is going to be 1 plus or minus, and then, so that's a 1, and then this would be negative negative is positive, so 1 plus 4 times 8 times 4, 129. So it's the square root of 129. And then divided by negative 16. So that's going to give us 2 possibilities because of the plus or the minus. So cosine of x equals something, cosine of x equals something else. And what are those numbers? So there's 1 plus the square root of 129, and that gets divided by negative 16. So that's a negative 0.772. And then do the same thing when this is subtract the square root of 129, and that is 0.647. And then I'll take a little break from that and start filling in the answers over here. So the second derivative was negative cosine of x minus 4 cosine of 2x. Next, we're going to find out where the second derivative equals 0, and then that's what's going to go right here, the inflection possible at. So now we need to solve these 2 little trig equations. So this one is saying, take a look at the cosine graph. So the cosine graph looks like this. And then make sure that you have a red pen and go to where the y value is negative 0.772, and then go straight across, and there's going to be two answers. One will come from, just take cosine inverse of a negative 0.772, 2.453. 2.453. And then this one is going to be 2 pi minus 2.453. So one of them is the 2.453, and then 2.453, oh, I needed to put 2 pi first. 2 pi minus 2.453 is at 3.83. And then for this one, so then take a look at the cosine graph again. This time with the red pen, put 0.647 on the y-axis and then go straight across, and there's two solutions for that. So for the first one, do cosine inverse of 0.647. So that is an 0.867. And then this one is to the left of 2 pi, so it's going to be 2 pi minus the 0.867. Of 5.416. So then we get 0.867 and 5.416. All right, then the second derivative is going to be about where is it concave up and concave down. But first, I'm going to transfer my answers over to here. So possible inflection points, that's those x values that we just got. And I'm going to put them in order. So 0.867, next would be 2.453, 3.830, 5.417. And then also, I need to put them on the number line. So 0.867 is approximately right here. 2.453, 3.830, and the 5.417. Okay, next, where is the second derivative positive and where is it negative? So the second derivative was equal to 0 here, and here, and here, and here, those four places. Not there, but just these four in the middle. So where is it concave up and concave down? Again, look at the original graph. So if you look at this part, okay, if you look at this middle part is obviously concave down, and this part is concave up. But this value, 0.867, that is a point of inflection because it's changing from this is concave down to this is concave up. So since it's concave down, that means the second derivative is negative, and then it switches to positive, and then at 2.453, then it's going to switch from being concave up to concave down. So this next interval would be negative, and then at 3.83, so then it's going to switch from concave down to concave up. And then this last part from 5.4, is it still on the screen? 5.417. So then this is going to be concave up, and then that's going to be concave down. Okay, so then just reading these intervals. So concave up are all the positive ones. So this interval would be 0.867 to 2.453, and then also this interval 3.83 to 5.417. And for concave down, there's this interval, and because we did not get the second derivative equal to 0 at 0, that means it's actually concave down as it goes through where x equals 0. So that one gets a square bracket, and then the 0.867 does not. Then there would be the middle interval, 2.453 to 3.83, and then the last interval. So you can even see it right here as it's going through where the 2 pi is. This is concave down. So that's why this is going to have a square bracket on the 2 pi. And now finally, what are the actual points? So that just comes from plugging in these 0.867. So 0.867 comma 0.485. And then the next one, 2.453, 2.453, comma, negative 0.58, and then 3.83, and the y value, negative 0.579, and then the last one, 5.417, and the y value is 0.487. All right, so you would then take that other work and attach it so that it all becomes one document. But that's how problem set number 8 goes. Enjoy.